Hello everyone, welcome back to another video of revision series by Excel Education Center for the grade 10 students. Myself Nabeel. Today I am going to discuss for the chapter Light, Reflection and Refraction. As you know people, this is one of the very important chapters among the physics, all the 4 chapters, right or not? It gives you around 10 plus marks. So let's go for discussing the questions. Are you ready? So the first question is here. So an optical device X is placed obliquely in the path of a narrow parallel beam of light. If the emergent beam gets displaced laterally, the device X is dash. See, from this particular question itself you can understand one thing. See, it is actually given that what is it? It is the emergent beam of light. So it is actually passing through a particular medium. So here it is an optical device. It can be a glass slab, it can be a prism, it can be a lens, whatever, right? So we have to find what it is. So it is actually passing through a particular medium, and it is actually what? Passing, it is emerging, which is getting displaced laterally. Okay, so here it is actually passing through that medium. So it is sure that it is not going to be what? A plane mirror, it is not a convex mirror. Okay, there is a reflection which is happening here, and here it is what? Reflection in both these cases, right or not? And you know what is happening in the case of a glass slab? So let's draw a small glass slab. Okay, and so think of like there is a light ray which is passing obliquely. Okay, so then what is it? At a particular angle. So here there will be a normal, here, and then it is actually moving what? Towards the normal, because this is air and this is actually what? A glass slab. Okay, this is glass slab, so this is a denser medium. So what? It moves towards the normal. Okay, and once it reaches here, again it is actually moving from another medium to another, what is it? Glass to air. So what happens here? It will be moving away from the normal, right or not? This is actually the path of the light, right or not? And what if I actually extend the original path of the what? Incident ray? It will be actually moving what? Laterally. If you draw the perfect picture, you can see that there is actually a lateral displacement which can be seen. So this actually is happening in the case of what? A glass slab. So what is the answer for this question? So here the optical device is actually what? A glass slab, right or not? Okay, so this is the first question. Let's go for the next question. Ready? So next question is here. To get an image of magnification -1 on a screen using a lens of focal length 20 cm, the object distance must be. Okay, before I go to the question, I'll just give you a small idea about the magnification and the values. Okay, so what is actually the magnification state? Okay, so magnification is always given with a sign and a number, right or not? So which is magnification is always given as plus or minus x. X can be a number. Okay, so what is this plus indicating? This plus is indicating virtual. It is a virtual image, right or not? And what is this indicating? Negative indicating this is actually what? This is actually a real image. This is actually a real image. Okay, so real and inverted, virtual and erect, right or not? Now what is the value of magnification is equal to 1? If the x value is equal to 1, this indicates it is of same size. Now what if the magnification is greater than 1? What is it? It is enlarged image. It is actually an enlarged image. Ready? And then magnification less than 1 means it is diminished. Okay or not? Now what is the value which is given here? Magnification is given which is equal to -1. Magnification is equal to -1 means what are the indications here? The minus indicates it is real image, and then the next one is what? Real inverted. Okay, inverted, and it is of the same size. It is of the same size. Okay, so next listen here. Real inverted same size. Who actually gives this particular thing? It should be actually what? It should be a concave mirror, right or not? It should be a concave mirror. The only mirror who can give you real inverted and the same size is what? Concave. Okay or not? So let's go for what is the question fully here. Okay, so to get an image of magnification -1 on a screen using a lens of focal length 20 cm, then the object distance must be. Okay, so we have to get the magnification is equal to -1. When you will get the magnification which is equal to -1? When the object is kept at C. Okay or not? When the object is kept actually at C. Ready? Okay, so what is it? The object is kept at C. Ready? Now think of one thing. When the object is kept at C, what is it? The focal length and C. It is like what? We have the relation focal length is equal to R by 2, right or not? So if the focal length is given, which is equal to how much? 20 centimeter, then where should the object has to be placed? The object is placed at C, right or not? So what is U has to be? U have to be 2 times of this, which will be 2F, which will be 40 centimeter. To be clear with that, it should be negative. Here also it should be negative. But here we have only what? The magnitude which is given. So you can just keep the answers only. What's the answer here? It is 40. You understood, my dear students? Okay, so you understood the way of going with this particular thing. I have actually added this particular thing along with the question so that like you will be understanding this particular thing. Ready? Understood or not? So let's go for the next question. Ready? Okay. So what's the next question? So this question is actually from what? Refractive index. Okay, so refractive index. If the absolute refractive indices of two media x and y are 6 by 5 and 4 by 3. Okay, so what are the refractive index? Nx is equal to 6 by 5. Next is Ny is equal to 4 by 3. Okay or not? It is 6 by 5 and 4 by 3. So it is actually given in what? Fractions. Okay, now what is to be found? Absolute refractive index, index means what is it basically? It is a refractive index itself. Okay, and now we have to find the refractive index of y with respect to x. This is basically relative refractive index. What is it? It is relative refractive index. And how do we find the relative refractive index? Relative refractive index is like we are comparing the refractive indices of two medium. Okay, so we are actually comparing with respect to another medium. So think of like there is two mediums, 1 and 2. So refractive index of 1 with respect to 2 is equal to n1 by n2. Okay or not? It is what? N1 by N2. Likewise, in this particular question, what is it? You had to find the refractive index of y with respect to x. So it will be Nyx. This is what you have to find. Nyx. So it will be what? Ny by Nx. Ny by Nx. Ready? So how you have to find the answer? So what is it? What is Ny here? Ny is how much? 4 by 3. Ny is 4 by 3. And then what is Nx? Nx is what? 6 by 5. Nx is 6 by 5. Ready? Okay, so now what is it? Here this can be written as 4 by 3 into 5 by 6. Now multiplying you will be getting 20 by 9. Right or not? 20 by 9 on cancellation it will be 10, sorry, yeah, it is not 20 by 9, sorry, 20 by 18. 20 by 18, right? So which will be on cancellation, you will get what? 10 by 9. Let's check whether there is an option like this here. So here the first option itself is right. Understood or not? So this is basically what a question which is from the refractive index, and which is basically what? The relative refractive index. Understood or not? Okay, don't forget this particular equation. Refractive index N is equal to C by V. Refractive index N is equal to C by V, where C is the speed of the light in vacuum and then V is the speed of the light in whatever the medium we are finding the refractive index. Clear or not? Now let's go for the next question, which is actually from the assertion reason. Okay, so what is the fourth question? Assertion. When light travels from air to glass, the speed of light decreases and the ray bends towards the normal. When the light travels from air to glass, okay, air to glass means what is it? It is actually moving from rarer medium to denser, right or not? Rarer to denser, the speed of light decreases. I'll tell you the explanation based on the refractive index and speed. So what is it, you know? The refractive index is actually what? Inversely proportional. The refractive index is actually inversely proportional to the speed of light, right or not? So what is it? If the refractive index increases, optical density is increasing, right or not? So optical density increasing means like the speed of the light has to decrease, right or not? So here, what is it? And one more thing, if it is actually moving from a higher density, or basically like from a denser medium to lower, rarer medium, it has to bend towards the normal, right or not? For that, it's better like you can just remember this particular code. What is it? Draw. You can remember this particular thing. What is it? Draw. What is draw? Draw means denser to rarer. What is it? It will be denser to rarer. It will be away. If denser to rarer is away means what? Rarer to denser, it will be towards the normal, right or not? So let's go. What is this? Again, we can go for this. When the light travels from air to glass, the speed of the light decreases. Yes. Why? Because refractive index, it is basically going from rarer medium to denser medium. So the refractive index is increasing. The speed of the light will be decreasing. Clear or not? So now what happens as a result? The ray bends towards the normal. Yes, it is true. So what is it? Assertion is true. A is true. Now let's go for the next reason, whether the reason is giving you the right answer. Refractive index of the glass is greater than that of the air. Yes, that's what we have written here, right or not? Refractive index in the case of air is, it is rarer medium, glass it is denser medium. So are we getting the right this particular reason here actually? So yes, R is also true. R is also true. So that means assertion is true, a reason is also true, and is the right explanation. So you should go for the option A. Understood or not? One small advice, people, whenever you are given with both the statements true, whenever you are finding the answer in which like both the statements is true, you should be very careful. Only if it is the right explanation, you should go for what? Option A. Or else you should be, if it is actually the statements are right, but like if it is not the right explanation, you should be going for the option B. Be careful. Okay, so this is the question number 4. Let's go for the next question. Okay, what's the next question? The mirror used in searchlights are concave, spherical. Okay, concave, spherical. Okay, in concave spherical mirror, the image formed is also always virtual. The mirror used in searchlights are concave spherical. Is it right or not? See, I'll tell you what is the application of this particular concave mirror in the case of searchlights. So think of this is actually a concave mirror, and obviously this will be having an optical, pole will be there. This will be having a focus. This will be having a center of curvature, right? Now, what is actually the principle behind the searchlights actually? You actually will be keeping the light at the focus. The light will be, or the bulb will be kept at the focus. So if the light is, or the bulb is kept at the focus, what happens here, the light will be moving in all directions. Along with that, this will be moving towards the surface of the mirror also. Clear or not? And we know one rule. What is it? If the light ray is passing through the focus after refraction, it moves, it will be reflecting parallel to principal axis, right or not? So this will be reflecting like this. This will be reflecting like this. Clear or not? Okay or not? So which actually gives us a strong beam. So in the case of actually the headlamps of the bikes, cars, and in the case of searchlights, in the torches, everywhere, like what we are actually doing is like we'll keep the light at the focus. So what happens? This light will be moving into the mirror, and this gives, after reflection, will be giving you a strong beam. Clear or not? Understood or not? Okay, and the opposite is actually happening in the case of solar furnaces, where you are actually using the heat which is produced by the sun and which is actually used to melt and melt the metals and all, right? What is happening is like the strong beam of light and heat which is coming from the sun, which is coming from infinity, right or not? All those will be focused at the focus, right or not, which gives us a very strong heat and light. Understood? With which we can actually melt the iron, right? Okay, so here we can say that like the mirror used in searchlights are concave spherical. It is correct. So we can say that A is true. The statement A is true. Now let's go for the next. In concave spherical mirror, the image formed is always virtual. Is it actually the right answer? The concave spherical mirror, the image formed is always virtual. No. In the case of concave mirror, concave can actually form real image also. It can also form virtual. Virtual only forms when the object is kept between F and P. Clear or not? So here, this particular statement is false. It is not Understood or not? So we can say here the assertion is true, reason is false. If any of the statement is false, there is no confusion. You can actually go for either C or D. Clear or not? Here the assertion is true and the reason is false, so you can go for the option C. Clear or not? Okay or not? So if it is like both the statements are true, then only you should be very much more careful, okay, or else it is easy to decide. Okay, now these were the MCQs and assertion reason, and for your information I'll tell you one thing, people, all the questions which we are discussing today is actually the questions from the board question papers only. So this is a kind of way the questions will be asked. Okay, so please be careful on deciding whatever the answers. Please always cross check for each and every questions. Okay, now let's go for another question. Okay, next question is here. So an object is placed at a distance of 30 centimeter. So what is it? Before we actually read the entire question itself, we can actually start writing the things here. So what is it? Here the object is kept actually at a distance of 30 centimeter. Okay. So U is always negative, right? U is always negative. Whatever if it is, like this a mirror or a lens, whatever it is, U is always negative. So we got U equal to minus 30 from the optical center of a concave lens. Concave lens. There is something which is very interesting about concave lens. What is, everything which is basically the focal length, object distance, image distance, everything, all of these things are actually what, all of these are negative. F value, U, V, everything is negative. And one more thing is the V, whatever you are finding, will be always less than focal length. Will be always less than focal length. That is actually a tip for actually finding your answers. I'll tell you what is happening here. So you are actually given with what? An object which is placed at a distance of 30 centimeter from the optical center of concave lens of focal length. 20 centimeters of focal length is how much? Minus 20 centimeters. Use the lens formula to determine the position of the image formed in this case. You had to find the V, isn't it? V has to be found. So before we actually find the value of V, we know certain informations about V. What are the informations, people? We know V is negative, right or not? V is negative. And what is the F value? 20, right or not? The answer should be less than 20. That is my prediction. So before we actually find the answer, like we actually have some guess. Okay or not? The answer has to be negative. The answer has to be ranging in between these values. Clear or not? 0 to 20. Clear or not? Let's check whether it is coming in the right way or not. Ready? So what is the equation you have to use? 1 by F is equal to 1 by V minus 1 by U. Be careful. Don't make mistakes with this lens formula and mirror formula. You always get confused with this thing. Okay? So don't make any mistakes here. Now, you have to find V, right or not? So you have to take another mistake. What you will be mistake is like what? When you shift this particular thing. So what is it? You can take this entire thing. So what is it? Here 1 by U has to be taken this side. So what is it? 1 by V is equal to, if this minus 1 by U is taken this side, it will be 1 by F plus 1 by U, right or not? This minus 1 by U is taken to this side, it will be plus 1 by U, right? So 1 by V is equal to 1 by F plus 1 by U, which is equal, now you can apply the values, 1 by F, 1 by minus 20 plus 1 by minus 30. Okay, now which is equal to, cross multiplying, it will be 30 plus minus 20 divided by 600, and you can actually know whether the answer is going in the right path here itself. Why? You know what, your answer is supposed to be negative only, right or not? And then here this gives you a negative answer. What is the numerator gives you a negative answer. This is what it is positive, so the final answer will be a negative answer, correct or not? So what it will be? It will be minus 50 by 600. This is actually 1 by F. Okay, don't forget. So F is equal to 600 by 50. So cancel. It will be 60 by 5. 60 by 5. I'll tell you another trick for this particular thing. What is it? Any number which is divided by 5, you can do one small trick. What is it? Make that number double. So 60's double will be what? 120. And put a decimal to the what? To the left. 1 point to the left. So the answer will be what? 12. Okay, we have a negative here, okay, so which will be minus 12 centimeters. Understood? And we actually had a prediction before. What is it? Our guess before was actually correct. What was it? Here answer has to be negative and it has to be ranging which is less than minus 20. The answer is less than what? Minus 20. Clear or not, my dear students? Okay, so please don't forget to use this particular trick so that like you never make mistakes. Clear or not? Most of the times the numericals will be asked for 3 or 4 marks. Okay, and for all questions from the chapter light, there is many easy ways. Okay, I'll add on to with this particular thing here. In this case of what? F and then U and V, here everything is negative, right? In the case of convex mirror, you have to understand U is always negative, F and V has to be positive. And one more thing is that the V value in the convex mirror has to be less than what? Focal length. The V value has to be always what? Less than the focal length. Clear or not? Ready? Now, can we go for the next question? Okay, so here is the next question. So what is it? A convex mirror used for rear view on an automobile has a focal length of 3 meters. Be careful here. It is 3.0, right? 3 meters. Okay, so what is it? It's a convex mirror. Just before only I have said something about that. Okay, convex mirror used for rear view mirror on an automobile has, in certain situations, you know what, this particular statement won't be even given. Convex mirror, you have to understand what is it here. Automobile rear view mirror, then what? Junction mirror or the parking lot mirror, and then what next? The side view mirror. All 3 of these things is basically what? Convex mirror. Okay or not? And dentist mirror, makeup mirror, and shaving mirror. This is basically what? Concave mirror, where the object is kept between F and P. Actually, applications with this concave mirror is much more. Okay. Now, so what is here? So the focal length is 3 meters. 3 meters. 3 meters. Next one is also meters, so no problem with that. If any of the quantities is in meters and the other quantity is not in meters, if it is in centimeters, make sure you convert to the same units. Okay, either to meters or to the centimeters. Ready? Now, a convex mirror used for a rear view mirror on an automobile has a focal length 3 meters. Okay, so this is convex mirror. I have said you this is actually positive, right or not? If the bus is located at 6 meters from this mirror, okay, use mirror formula to find the position of the image of the bus. So what is it? U is equal to 6 meters, but here is this object, so it has to be minus 6 meters, right or not? Now you have to find V. Likewise, what we did in the previous question, we also have certain what guess for the answer. What is going to be in the V? I have the what guess here. What is my guess here? V has to be positive. V has to be what? V has to be less than the focal length. Ready? Let's check whether this particular things are coming again or not. Ready? So let's go for the formula. What is actually is to be used here? Here it is what? Mirror formula. Okay, it is given in the question itself. Okay, so 1 by F is equal to 1 by V plus 1 by U. Now take this plus 1 by U. This time it is plus 1 by U. So 1 by F is equal to, sorry, not 1 by F. We have to find 1 by V, right? 1 by V is equal to 1 by F minus 1 by U, right or not? So now giving the values 1 by F, so 1 by 3 minus 1 by U is what? 1 by minus 6. Now itself you can understand the answer is going in the right path. How? This is what? This is 1 by 3. This is minus 1. This will be plus. So it will be what? 1 by 3 plus 1 by 6. 1 by 3 plus 1 by 6. This will be what? 6 plus 3 by 18, which will be 9 by 18. On taking the reciprocal, it will be V equal to 18 by 9, which is equal to 2 meters. This is positive, and this is what? 2 meters. Is it less than the value of what? F. F is 3. The value of V is how much, people? The value of what is V is 2 meters. Understood, my dear students? Actually, most of you actually thinks like the chapter light is very hard, but it is actually not. It is actually very easy. Understood? It is actually the easiest chapter among all the chapters. Why? Because like we actually have certain easy ways to understand the concept, what to say, the answers actually. Understood? All the questions which is coming from mirror formula, which is actually coming from the lens formula, magnification, HI, HO, everything can be found by this kind of methods. Okay, so this question, like we have actually found the answer before itself, right or not? And now this question also, like we have actually found the answers before, right or not? Now let's go for the next question. Ready? Are you ready, my dear students? Okay, now next question is here. This question is actually asked from the power. Okay, the power of the lens is minus 2.5 D. Okay, so what is the power actually? Power is given 0.25 diopter. Power is given which is equal to 0.25 diopter. Okay, so what is a power which is indicating negative actually? What is power which is indicating negative? So listen, we have to understand there is two lenses which you have to study, right? So what is it? Convex lens. Convex lens has the focal length which is positive. Convex lens which is having the focal length what? Positive. And concave which is having what? Focal length which is negative. What is actually power? Power is the degree of convergence or divergence, right or not? And the power is basically what? The reciprocal of focal length. So this is basically connected, right or not? So if the focal length is negative, what is it? What is the connection here, people? We can say power is equal to 1 by f, right or not? Power is equal to 1 by f, right? So if the f is negative, power has to be negative, right or not? So if the given value is having a negative in the power, if the value of the power is negative, then you can clearly say it is actually what? Concave lens. It's actually concave lens. Clear or not, people? So from this also we can understand one thing. See, most of the students who are actually wearing glasses will be having what a concave mirror will be. They will be using concave. Whenever you are asking their powers, they will be saying minus. Okay, it will be minus 2 or minus 3, something like. Okay, because the eye defect which is actually seen in youngsters is basically what? Myopia. Okay, anyway, I'll come back to that. So what is it here? The type of the lens and its focal length is to be found. Okay, so what is it here? We understood it is, since the power is negative, we understood it is what? Concave. If it was positive, it should be convex. Clear? Now focal length has to be found. What is focal length, people? So what is the focal length? Focal length is to be found. Focal length is equal to 1 by p. What is it? Focal length is equal to 1 by p. So what it is? Power, say it is 0.25. 1 by 0.25. The one common mistake most of you people make it, like you know that power is equal to 1 by f, which is equal to 100 by f, which is in centimeters, right or not? So likewise there is no particular equation for here. Focal length, which is like always the power will be given what? In diopters only. There is no units. Okay, so this is already in SI units. But if the focal length is given in centimeters, you have to convert into meters because it is not the SI unit. Centimeter is not the SI unit. We have to convert to SI units, right? So here we are already given with what? The SI units. Clear? So what is it? Focal length is equal to 1 by p, which is equal to 1 by 0.25. Okay, 0.25. Now what is 1 by 0.25? This is basically what? 4 times, like, isn't it? 0.25 into 4 is what? 1. So now next one is which defect it is, the eye defect for which it may be used as a corrective lens. If the lens used is concave, it has to be what? It has to be myopia. It has to be myopia. Okay or not? That's what I have said few minutes before. What is it? If you are using a convex lens, it is hypermetropia, and if it is actually a concave lens, it has to be myopia. Clear or not, my dear students? Ready? Now we have one more question here. So what is it? The nature and the size of the image formed by this lens when an object is placed between f and 2f from the optical center of this lens. So it is basically f and 2f. So here wherever we actually keep the object, it is rather than like at infinity, we'll be getting what? An image which is actually what? Which is virtual. Always it will be given with what? Virtual only. Virtual, erect, and also it is what? Diminished. Virtual, erect, and diminished image. Okay, so the image which is actually obtained from the concave mirror will be, concave lens will be what? Virtual, erect, and diminished. Clear, my dear students? Okay or not? Okay, so this is actually a question which is from what? power, okay, power of the lens. Okay, so I have tried to include most of the topics from this chapter. Okay, so like so that like I can explain the theory also. Okay, now let's go for the next question. So what is the next question? Okay, so what is it? Observe the following diagram. So you are actually given with a diagram, and then you have to compare what? Speed of the light. Okay, and then next is optical densities of the three media A, B and C. So we have three media, isn't it? So which is like we have three mediums which is given A, B, C, right? Also give justification for your answer for of any of one of the two cases in terms of the refractive index A, B and C. I think we have, yeah, we have one more set which is actually left here, like we'll come back to this. Okay, now we have to compare the speed of the light and the optical densities, right or not, my students? Now how do we find this? Okay, so for that we have to do one thing. What is it? See, check what is the ray of light which is passing. Okay, so this is actually moving from the medium A. It is moving without any refraction to the medium B, right or not? It is coming from A and then moves towards the B without any refraction. If there is no refraction, what is it actually indicating? This is actually having same, it is actually having same refractive index, basically the same medium, okay or not? So what is actually refraction? Refraction is the bending of the light when it is actually passing from one medium to another medium, right? Here there is no change in the medium. Okay, even though it is given medium A and medium B, the refractive indices of A and B is same, clear or not? So we can say NA is equal to NB. And what is actually happening once it reaches here? Once it reaches here, it is actually moving away from the normal, right or not? Isn't it? It is actually moving away from the normal. So it is basically what? Medium C is actually what? Medium C is actually a rarer medium. So we can say if it is rarer, the refractive index has to what? Decrease. So here we can say we have this NA equal to NB, which is greater than NC. Okay or not? And this is basically the optical density itself. But before that, we have the first question which is asked, which is the speed of light, right? What is speed of light? N is inversely proportional to speed of light. Isn't it? N is inversely proportional to speed of light. So what is it? If the refractive index is greater for NA and NB, then the speed of light will be less for them. So we can say the first question's answer can be what? VA is equal to VB. There won't be any change in the speed of the light, right or not? So VA is equal to VB, which is less than VC. Why? Because here the refractive index is greater for these people, what? A and B. So their speed of the light has to be less, clear or not? Okay, so VA is equal to VB, which is less than VC. Now what is the next one which is asked? What is the next one? Optical densities. Optical density is basically refractive index itself. Okay or not? Optical density is refractive index, so we can say which is what? NA, which is equal to NB, which is greater than NC. Okay, so the main point, this can be a 2-mark question and all. Okay, so if you are actually asked with this question, so you have to always mention the physics here. The physics here is what? N is directly proportional to 1 by V, clear or not? Here it is like this is the particular statement which you have to mention here. Okay, so this is actually the answer for this particular question. Ready? And we have actually a sub question also. Let's go for checking that. Okay, I think what is it? Yeah, also give justification for the answer of any one of the two cases in terms of the refractive indices of A, B and C. Okay, so what is the next condition? Redraw the path of the ray of light through the three media if the ray of light starting from medium A falls on medium B. So think of like you actually have the glass slab here. Ready? Now next is what? Obliquely, and the optical density of medium B is made more than that of A and C. So A is there, C is there, B is what? A denser medium. B is a denser medium. So you can just take it the example of a glass slab itself. So A will be what? Air. This will be air. This will be what? This will be glass slab. This will be again what? Air. Got it? So what is happening here? See, listen. When it is actually obliquely and optical density of medium B is more than that of A and C. So it is actually obliquely means it is coming at an angle. Now you have to draw the normal Okay, the normal is supposed to be dotted line. Okay, and then it moves towards the normal, right or not? It is moving towards the normal, and then once it reaches here, this is actually a denser medium, and from denser medium to the air, it is actually a rarer medium, so it is moving away from the normal. Okay, it is moving away from the normal. So this is actually the path of the light in the case of the first question, right or not? Now the next one. What's the next one? Let's check. What's the next one? The ray falls normally from the medium A to medium B. What does it normally means? A ray of light which is passing normally means what? It is coming at an angle of 90 degree, which is basically what? Perpendicular. What is it? The ray of light is perpendicular to the what? This particular medium. Basically it is moving through the normal itself. So okay, so we have the normal here. Okay, so if this particular ray of light is actually coming through the normal, this won't be having any angle of refraction, right or not? So it will be moving straight directly without any refraction. Without any refraction, it will be moving. Clear or not? We know sin I by sin r is equal to what? A constant in which, like here, there is no angle of incidence itself, so it won't be having any particular refraction. It will be moving directly without any refraction. Clear or not? So if any ray of light is actually passing normally, it is falling normally from any medium to whatever the medium it is, it won't be getting refraction at all. Clear or not? So this is actually the what to say diagram for the next question. Clear? Okay or not? Okay, so we have the next question, which is actually the last question in today's discussion. Ready? Okay, so we have one more question. What is it? See, analyze the following observation. Okay, this particular question has been seen number of times in many of the questions. Okay, so what is it? Analyze the following observation table showing variation of image distance v with object distance u in case of convex lens, and answer the follow without doing any calculations. Okay, they have specifically said you have to do this without any calculation. So can we try to find the answers with what to say, without doing any calculation? You are actually given with certain observations, 1 2 3 4 5 6 observations is given, and now you have to check which among, like we have certain questions below, we have to answer for that. Okay, so what are the, this is basically object distance is given and then image distance is given. They have specifically said this is actually convex lens. This particular question can be asked in the case of concave mirror also. Okay, the easiest way to find here it is like, always remember one thing, in the case of convex lens, okay, and in the case of what to say, concave mirror, in the case of convex lens and in the case of concave mirror, there is one interesting thing. What is it? You know, here both of the image formations are same. Here convex lens is actually, there is refraction happening. In concave mirror it is what? Reflection happening. Clear? But one thing is, like most of the image formation when an object is kept at particular position will be same here. Okay, so understand one thing, at particular position which is at C, the image will be like the object distance and the image distance will be what? Same. At C, in the case of lens it will be at 2f1, right? Okay, in the case of lens it will be at 2f1. Here the u and v will be same, but one small difference is that in the case of concave mirror it will be u and v will be same with the sign also, and the magnitude also will be same. But in the case of convex mirror only the value will be same, the sign will be different because it is refraction, so it will be formed in the other side. Okay, now what is it here? This particular clue has to be taken in this particular question. What is it? At C, u and v is same. So we can know that here in any of the situation where the u and v is same will be giving you the right answer. So what is it? Is there any option which is giving u and v the same? That will be a right option here. So what is it? This is actually a right, isn't it? So observation number 4, look at this observation number 4. This is -4 plus 4, sorry, -40 and plus 40. Okay, so -40 and plus 40, this can be an answer, right or not? So if you have a lens, the object distance will be always negative, and there is refraction and the image will be formed the other side at 2f2, right or not? Object will be kept at 2f1, image will be at 2f2, right? So this can be a right answer. And if 2f2, okay, so think of like if 2f2 is actually a right answer, if 2f 2 or 2f1 is equal to how much? 40 centimeters. Then what will be focal length, my dear students? It will be half of this. This will be 20 centimeter. Since this is actually a convex lens, the focal length has to be positive. We have found the answer. Focal length is equal to positive. Okay, so determine the focal length of the lens, give reason for your answer. So here is what is the answer and here is the explanation. Clear or not? Make sure whenever you are actually asked with any reason, give reason based questions, make sure you write the theory behind it. Okay, the perfect physics should be explained. Clear or not? Okay, let's go for the next question. This is actually a 5-mark question, so you should be careful on finding the answers. Okay, maybe like this focal length will be giving you how much, you know, finding the focal length will give you 1 mark and give reason will be giving you what? 1 mark. Next question. Find the magnification of the image formed in the observation number 3. So which is observation number 3? This one. Okay, this is observation number 3. You have to find the magnification. Always remember this is magnification. So what is it? Like this is actually lens also. Magnification is equal to V by U. Don't think this is minus V by U. Minus V by U goes for lens, sorry, mirror formula. Okay, so what is this? This is actually what? V is how much? 40. And then next is what? Minus 40. Okay, the answer will be what? Minus 1. And what is this minus 1 indicating, people? This is real, inverted, and it is of same size. Real, inverted, and it is of same size. Clear, my dear students? So we have actually found the magnification which is equal to minus 1. Now, the numerical value of magnifications in the case of observation 1 and 2 is same. The numerical values for the magnification in case of 1 and 2 is same, right? Okay, let's check. What is it? 60, 30. What is it? V by U, 30 by 60. Okay, what is it? It will be 1 by 2, right or not? What about, sorry, yeah, and what about, no, is it, sorry, 1 and 2, right? So it is like here, this one, these two things. 60 and 15, 60 and 15. So it will be 1 by, sorry, 4, right? It will be 4. 60 by 15, it will be 4. And what about here also? It will be also 4. But there is actually a small difference. What is it? Here the magnification value, actually, the numerical value is actually same, which is basically what? Both are what? 4 only, but here the signs are different. The signs are different. So what is actually happening in the case of observation number 1? Observation number 1, here magnification will be what, you know, which is minus 60 divided by minus 15, which will gives you how much, you know, 4. This is plus 4. Ready? Now what is the observation number 2 gives you? Observation number 2 gives you magnification which is equal to 100 by 25 minus 25, so it will be minus 4. The magnification will be how much? Minus 4. Now what is the difference between these two? This gives you plus 4, this gives you what? Minus 4. What's the difference here? Here the answer has to be what, you know, this is plus 4, this is indicating what? Enlarged. The image is what? Enlarged. And next one, it is what? Real image. Then it is what? Inverted. And to be much more clear, you can say the image is what? 4 times bigger than the object. The image is what? 4 times bigger than the object. Now, what about this particular thing? Here also don't think that minus 4 means it is a small number. This is actually separate. The sign is different, the value is different. 4 means again it is what? It is enlarged. It is what? Enlarged. Next one, plus indicates what? Sorry. Oh, okay, sorry. I have actually written here, this is plus 4, right? Plus 4 means what? Plus 4 means it is virtual and erect. Okay, sorry for that. So it is what? Virtual. It is virtual and erect. Okay, sorry. And then here it is what? This is enlarged again. This is enlarged again. But here it is what? Negative, which is real and inverted. Okay, or not? Real and inverted. Clear, my dear students? So this is the way in which like we can actually understand. I think this is the first, the similar question was actually discussed in the first one, right? I have actually explained about like magnification, whether it is plus or minus, all these things. Okay, so this is actually the answer for this. Always understand one more thing, like this is actually 5-mark question. So the explanation should be very detailed and you have to explain in the proper way. Okay or not? So this was actually the set of questions from the chapter light, reflection and refraction. I have actually tried to collect maximum amount, like maximum number of questions, which is actually very much important. Okay, so hope this session finds you well, okay, and you should give your all your comments in the chat, okay. Until then, like, we'll meet and again with another video. Until then, goodbye. Thank you.